Hello and good day everyone. My name is Muhammad Shafiq bin Kasmazuli and my message number is AE190107, and now I will show you the simulation on experiment 6, activity 1. So this is the circuit that we are asked to do. So here we have our DCV source, which is 60 volts. This is our voltmeter, our ammeter, our wattmeter, and our resistor, variable resistor. So in this experiment, we are going to determine the volt, the current, and the watt by changing the resistor, the value of resistor, and without changing the value of voltage. So now I will show you the simulations. First, we are using 100 ohms of resistor. So after done the simulation, we get our voltage is 60 volts, our amperes is 0.6 amperes, and our watt is 36 watt, our power. And next, I will change our resistor value to 500, which is the maximum value example that we need to do. Okay, now, see, the voltage is still the same, which is 60 volts. Our current is decreased, which is 0.112 amperes. And our watt is also decreased, which is 7.20 watt. Now I will show you. So this is the simulation results that I have been done by changing the resistor, which we use 100 ohms, 200, 300, 400 until 500 ohms. And this is the answer that we get. So basically what we get here is our simulated voltage is same, while our simulated current and simulated power will decrease when the resistance is increased. So they are inversely proportional with each other. So this is our calculated power and calculated power in percentage by using manual calculations. So that's all for activity 1. Okay, now for the activity 2. In this activity, we are going to determine our voltage and our power. So in this circuit, we are using our AC source, which is we have 100 volts of amplitude and our frequency is 50 Hz. And here we are using resistor 100 ohms. So let's take a run first. So in this activity, we are going to use our variable resistor, which is 100 until 500 ohms. So this is the result of voltmeter we got, 50 watt, and our voltage is 70.7 volts. So now let's change our resistor to 500 ohms, and let's see what the result we get. So we can see that our voltmeter is the same, which is 70.7 volts, and our voltmeter is decreased to 10 watts. And here is the manual. Here is the simulation of our circuit. So here we have 100 ohms, 200, 300 until 500 ohms, and here is the results. So as you can see, what we get here is when the resistance is increased, the simulated peak voltage will remain the same, while the simulated real power will decrease from 50 watt until 10 watts. So here is the calculated manual real power to prove that the simulation and our calculation is same answer. It's all for activity 2. Thank you.
Okay, Assalamualaikum. And hi, my name is Muhammad Zaimul bin Mazlan and my metric number is AE190070. And now I present about the activity 3, simulation of electrical power measurement in an AC circuit with capacity load. So for the first part, we need to calculate the AC for every capacitance given. As you can see here, the value is already calculated for every capacitance. And next, we need to find the impedance and the angle for the impedance for every capacitance and every load given. After that, we need to record it in our table here. So after that, we need to find the simulated apparent power and simulated real power in the simulation in Proteus. So basically, this is my simulation. So we have the V source of 100 watt and 50 hertz and resistor of 100 ohm and capacitance of 2 microfarad, and we run the simulation. After that, we get the value is equal to 0.20 watt, and then record it in our table here, 0.20 watt. And then we need to find the next part here by changing this to VA. And then run the simulation. And then we got the value of 3.14 VA for the simulated apparent power here. So next step is the same, just changing to this 4 microfarad for the capacitance, and repeat the same step. So as you can see here, change in here, and by changing the capacitance here, and then run the simulation. Is equal to 6.24. Then record in our table here, and then do the same step for all the load here, and this is the final value that we got. And then for the last part, we need to calculate the power factor here by using the data that we get. So this is the power factor that we get for first load is equal to 0.064, and next is equal to 0.125, next is equal to 0.186, and next is equal to 0.243, and last is equal to 0.299. And that's all for me for the activity 2. For the activity 3. Okay, now I'm going to explain about the activity 4, which is for the electrical power measurement in an AC circuit with inductive load. For me, it is same as before, just changing the load to the impedance, inductive load. So here, first we need to find the impedance for every load. So same step as before, calculate by the data given, and then we get the impedance for every load here. After that, we need to find the simulated apparent power and the simulated real power. So in the simulation here, for the first load is equal to 0.02 Henry, and then 100 ohm, and same with source, which is 100 watt and 50 hertz. So start the simulation here, and then we get this value equal to 49.6 watt, and record it in the table here. Then after that, you need to change to find the simulated apparent power here. Change to VA, and then run the simulation. Again, we get the same value is equal to 49.6 VA. Then record it in our table here. Next thing, we need to change the load is equal to 0.004 Henry, and repeat the step. So here, changing 0.04. Start the simulation, and then run. And then we got this value 49.6 VA for the apparent power. And then for simulated real power, this is the same, change to watt here. And then repeat the same step for every load. So this is the result that we get for every step. And next, after finding all the simulated apparent power and simulated real power, we need to calculate the power factor for every load here. So this is the calculation part for the power factor for each load. So as you can see, we get the value all is equal to 1. And then record it in our table here. So that's all for the activity 4. And thank you.